In Thread 22.4, one of the new features that's been added is the support for the GPU to trace polarized rays, which means that we can now ray trace polarization sensitive systems at high speed using our GPU in Thread MPC. So to demonstrate that here, I have a little system. It's a randomly polarized source, a lens group that is essentially taking our light source and splitting into 3 channels. In each channel, what we have is a pair of beam splitting cubes. The beam splitting cube at the bottom here will transmit S, reflect P. The P state that is reflected goes through a half wave plate and then is rotated to the S state. Then the upper beam splitter is essentially reflecting that to give us more light at our output plane. The output plane here is actually measuring the total power as measured behind this surface, which is an X analyzer. So to show this tracing at speed on the GPU, I'm going to turn on a much more complex source here with around 20 million rays. And I'm going to ray trace that. So here is the ray trace in action. It's tracing around 1 million rays per launch, and each launch is taking around a second. So we would expect this trace to be finished in around 20 seconds or so. So nearly done, just finished a little under 20 seconds. The output plane as measured on the GPU is measuring from a 1 watt source. It measures there's a total power of 0.9 watts. So because the source was randomly polarized to start with, that means a lot of the source power is being rotated into the actual polarization state that we want. It's converting around 90% of the light and kind of getting it to the plane of interest. That's the GPU answer. I did do the CPU trace a little earlier. That took several minutes. This is the output plane for the CPU, and we can see that's essentially the same answer. But that trace took several minutes compared to 20 seconds on the GPU.